So here we go with chapter 2.2, example 7. Let's read it as usual. For each of the following mappings, state whether the mapping is one-to-one, many-to-one, or one-to-many. Part 2, state whether the mapping is a function. So let's first of all look at the first one. If we take one value input, it goes to two values on the output. So that means in terms of mappings, it's one to many. Anything more than one gives us a many outcome mapping. So it's a one to many mapping. If we look at B, we can see already from the dotted line that one x value gives one output, and assuming the line goes on forever, every input has only one output, or all inputs. So all inputs, that's x values, have one output. And only one output. And only one output. Only one output. So if all the inputs, so one value, each individual value, gives only one output, that's going to be a one-to-one mapping. C. We have the same idea. Each input has an output, and again that's one to one. There is a problem with the 0 because that doesn't seem to have an output, but that doesn't stop it being a mapping. So we have each input, 1, has a unique output, so that's going to be one-to-one mapping. D. Here we can see each input has just the one output, but two inputs can have the same output. So that makes it similar. It means that we've got two values that go in to give one output. So that would be many. That would be a many to one mapping. Okay, because more than one input gives one output. Okay, and in the same way as part B, every input gives an output. Now, state whether it's a function, so part 2. So the key thing for something to be a function was each input has one output, but the output doesn't have to be unique. Yeah, so for a function, each input has an output, but it doesn't have to be unique. Yeah, in other words, there are more than one input could have that same output. So if we come down to these then, one by one, one to many, yeah, so part A, because we have many outputs, yeah, many outputs from one input, many outputs from one input, we conclude not a function. Part B, one to one, so each input does have a unique output, so that must be a function. Part C, it is a one-to-one mapping, so we may well think, well, this should be a function. The difficulty here is that when we put in 0, we don't get an output. So when x equals 0, no output. So each input doesn't have an output, therefore it's not a function. Part D, many to one. As long as we've got the 1 on the output and each input gives an output, yeah, so each one of these inputs gives an output. So long as we've got that, and only each input gives only one output, then that is going to be a function. Now, one of the interesting questions, and this is what your calculators do, and we've talked about this idea before, is how can we restrict this where we haven't got a function to make them a function? So if it's not a function, to make it a function, what would we have to do here? How could we make this a function? So we could restrict our range, yeah, our range, if we called this process up here f of x, then our range is f of x is a member of the set of real numbers, and f of x is greater than 0. In other words, it has to be positive. That restriction would then rule out our negative values, and so we would only get 1, 2 and 3, and that would change this into a function. Similarly, for y, for part C rather, the problem here is, we said earlier, was the x equal to 0. So here we can change it into a function by going the domain, the input values is x, a member of the set of reals, and x does not equal 0. And as soon as we rule out the 0, and we could put some curly brackets around here to show it's a set of values, and we could even write at the front here, x is such that x is a member of the set of reals, and so intersection with x not equal to 0. Okay, I hope that's clear. And I've just tried to introduce a little bit of set notation because often that's the way the exam would like you to write the answers.